All right, so we're going to do angles and angle measures. We've talked about angles before. It's not like the first time we've talked about an angle, but we're going to get a little bit more detail. So I'm going to put a little x and y axis right here. Right there. That looks nice and pretty. And I am going to talk about a couple things right here. So what we're going to do is we're going to talk about angles and the measure of angles and the degrees of these angles. So let's start right here in the middle. We call this the vertex. So this little thing right in the middle, we call the vertex. All right. And we have an x-axis, we have a y-axis. We've discussed that before. That's nothing new. But when we talk about angles, we're going to measure angles around this x and y axis. And in a bit, we're going to put a circle in here, and we're going to call it the unit circle. I've mentioned that before to you, haven't I? Remember we did those triangles that I said, let's make the hypotenuse 1. Remember that? And you're like, well, why do we make it 1? Well, I'm going to show you why we make it 1 here in a few minutes, okay? But right now, we have to know something about the angles of this thing. So when you go to the right, horizontally to the right, we use that as 0 degrees, all right? So if I told you to go 0 degrees, you could say go on the positive x-axis. This would be the positive x-axis, but that would be 0 degrees. Now watch this. I'm going to go counterclockwise. So which way is counterclockwise? Is it going up or is it going down? It goes up, okay? So this is counterclockwise. So I measure my angles counterclockwise to this. This is kind of like my starting point. This is my 0 degrees. So the positive x-axis is the starting point. If I go all the way to here, what do you think this angle is? Boom, boom. That should be pretty easy to see. If this is horizontal and this is vertical, how many degrees does it go straight up? Somebody tell me. 90 degrees, that's right. And so I'm going to call that 90 degrees right there. This is very important. I hope you're writing notes. I see a few people taking notes. Not everybody. Let's keep going. Again, you start here. That's 90, but what if we go all the way to here? How many degrees is that? Very good. It's another 90, isn't it? So 90 and 90 is 180. And you know about 180, right? If I'm turned this way and I turn completely in the other direction, that's 180 degrees, right? You hear people say all the time, well, I'm going to change my life 360 degrees. Do they really mean that? Probably not. What do they mean? They usually mean 180. Ever hear anybody say that? You probably heard somebody, I'm going to change my life 180 degrees. God got a hold of my life and he changed my life 180 degrees. Well, that's good because you were going in this direction. And if God changed your life and you were going in the wrong direction, where are you going now? You're turning around and going the opposite direction. But some people mistakenly say, God has changed my life. He got a hold of me and my life is different. And I've changed 360 degrees. And you're like, oh, I cringe. And I've heard people say that because what would happen if you go 360 degrees? You do in the same direction as you were going before, all right? So there's not much of a change. Would you agree? All right, enough of that. So there's your little biblical integration, to the lesson today. All right, so this is 180. Another 90 would put you at what? What's 180 and 90? 270. And then you could go up here, and if you go all the way around, excuse me, if you go all the way around, how many degrees are we back to? We're back to 0, but how many have we traveled from here all the way around? 360. So 0 degrees is going the same direction as 360 degrees. We could go around the circle a bunch of times, couldn't we? But most of the time, not all the time, but most of the time, we just go one way around the circle, all right? But there will be some times where we're going to go more than once. Everybody got that? You should be able to figure out what that is. Like if you go around the circle one time and then go a little bit more, what would this be? This would be 360 plus what? 90, which would be what? 450. Would you agree? Right? So you could keep going around the circle over and over again, but we're not going to worry about that. I'm just going to do, at least right now, let's get rid of this stuff. Let's get rid of the 360s, let's get rid of the comma, and let's get rid of all these dumb arrows, just because it looks ugly. And get rid of that. You're okay with the vertex now, right? You know what that means? All right, so there we go. Now, what I'm going to do, let's do this in a different color so we see it. What I'm going to do is draw another angle that doesn't go at these main points right here, 0, 9, because there's a lot of angles in between, right? I could go in between. This would be like, I don't know, 20-something degrees or whatever. You with me on that? So let's do this. I'm going to draw an angle. I'm going to draw my first one along the 0, and then I'm going to make another one like about right there. Okay? These are angles, so they technically keep going, so I could put arrows on the ends like this. Now, this is just vocabulary. This first side right here, it has a name. We call this the initial side. I'm not really going to be super picky on this, but it's in the book, so we'll say it. So this is the initial side of the angle, and we call this the terminal side of the angle. Terminal side. Oops. It means kind of where it ends, right? Initial, right, where you begin, terminal, where you end. So it's basically like this. You start from the initial angle, and then you're going to swing all the way to here, and that angle right there is made. So you've got an angle. You got two rays coming up from a common vertex, and that is an angle. All right? That's pretty easy. No big deal. Let's do this now. Let's grab this again. And let's push this up. For those watching online, I got this generic PNP monitor thing there. I have no idea why it's there. I must have clicked some kind of crazy button. I'm sure it'll go away if I restart the computer, but I'm not going to do that right now. So let's do this. Let's put and change the color of it so we can see it a little bit better. Okay, so there's a little bit of a red. And then let's take it right down the middle. Just trying to eyeball it here. So if I take it right down the middle, what do you think? This is 0, this is 90. So here's my terminal, or as my initial to my terminal. If it splits it right down the middle, go ahead, 45 degrees. Okay? And that's a positive 45 degrees. That's really important. So when you go counterclockwise, it's actually positive. Kind of counterintuitive, isn't it? You'd think it would be counterclockwise, it'd be negative, but it's not. If you go in this direction, that's a positive angle. What if I did another one? Let's just make this a different color. What if I made one, again, we're split in the middle. I'm just eyeballing it. But what if we go right here? Now, how many degrees is that? If I split it right down the middle? Well, I go, you said, I heard it, right? You go all the way up to 90, then how much further do you have to go? So if I went to there, it's 90 plus how much? 45, because I split it down the middle. I'm not always going to split it down the middle, but I did in this case. So this would be 45, this would be 45, and so what would your whole entire angle be? It would be what? It'd be 135. You with me on that? So that's how we describe these angles, okay? It's pretty important. We could go the other way. We could go clockwise. Like, Mr. Hamrick, you're going crazy now. I know. All right, so we could go clockwise. Let's change color. Let's put the initial side right there. And let's, we'll stick with 45. It just makes it a little bit easier for us to do the math. So we'll just go about right there. So we'll say we split the middle again, okay, and it's 45 degrees. So this little angle right there is 45 degrees. But do I call this angle 45 degrees, though? I can't call it 45 degrees. It's 45 degrees from the negative x-axis, but that's not where I want to find my angle from. I want to take my angle from the positive x-axis, or from the initial side, which would be at 0 degrees. So watch what I'm going to do. I'm going to go from here, and I'm going to take that whole thing right there. That's the angle. That's how I'm going to describe this angle right there. So let's do it. From here to here is what? Where my pen is. That's 180 plus another what? 45. Any idea how far that is? It's 225. That's right. So this angle would be 225. But I could go in the other direction. Let's do a different color here. I could go right there. So it's positive 225 degrees, but what if I go in the other direction? If I just go in the other direction, how many degrees is it now, this pink one? So that's 90, that's 45. So really, it looks like that would be 135, doesn't it? But it's not 135, because where's 135? We just did that a little bit ago. It's up in here, isn't it? In the second quadrant. So I can't call this 225 and also call it 135. So what do you think I'm going to do to it? I'm going to call it negative 135. Okay? What does the negative mean? It means you're just going in the other direction. All right? You're going down instead of up from that initial side. Make sense? All right. So that's not too hard, is it? So let's do this before we go to the radian stuff. We have to know this stuff before we do the radians because we're going to go all in different directions and stuff. All right. So what do I want to do? Let's do this. And it doesn't matter. So this is 0 degrees. What if I go the other way? We said this was 270, but what would it be if I went the other direction? What if I went down in the negative direction? What angle degree would this be called? I could call it positive 270, but I could also call it what? Negative 90, exactly right. Because I'm going in this direction. That's all the negative does with these angles. It just says what direction you're going. That's the only thing different about this. It's really not that hard. I said this was positive 180, but what if I go in the negative direction? What would I call this? Not negative 0, because remember, I got an initial side, but this angle goes all the way over here. So it goes, how many degrees is this? From here to here. How many degrees is that? That's not 0 degrees. It's 180 degrees. But I went in the negative direction, so it's still going to be 180, but it's going to be called negative 180. Just depends which direction that you go, right? So if I go in this direction, it's negative 180. If I go in this direction, it's positive 180. Still at the same spot, still the same measure, all right? But it just depends on the direction that you go. Now, what about up here? We did call this positive 90. So what am I going to call it if I go all the way around in this direction? What would this be if I called it a negative angle? Be negative 270. Okay? So those are some things you're going to see. It all depends on which direction that you go. All right? Everybody with me? Got some heads down, got some people catching up on their sleep from their long weekend. Well, it was a regular weekend, wasn't it? So I'd appreciate it. I'd rather not call your name out, but I will in a second if I just see your head down again. So let's everybody look up here. It's very important. There was a couple examples with this. I'm not going to go through this, but what I'm going to do is this. This is where, and I may not have enough time to get through all this because you know how I talk too much. But that's okay. I didn't have that stupid little generic PNP monitor thing there. All right, and let's do a circle. Let's see, where are my circles? Right there, and let's do a nice pretty circle. So let's move it over. Oh, that's pretty good right there. How's that? Let's blow it up just a little bit bigger. We're going to have to deal with that little thing right there. And let's make that half a point instead. Okay, so what we're going to do now is this. We know our angles. We know this is 0 degrees. We know that's 90 degrees. We know that's 180. We're going to stick with the positives right now. And we know that's 270, all right? What I want to do is this. Look at the length. This is where radians comes into play here. Let's see, maybe the pink will be easier to see. And I think I'm going to make it a little bit thicker just to show you. Watch this. You see that length right there? What would I call that length? It's a circle, starts at the center circle, and it goes to the end of the circle. What do I call that in a circle? We've done this before. It's what? It's the radius of the circle. Exactly right. Okay. Now, I don't have like a really good way to do this. I tried and tried, but I don't think there's any really good way I can do this. But, are you with me? Okay. But watch this. Pretend. When I was doing this full time, I had all these things that I used to do this. But pretend I have a cardboard circle. Okay. So I got a circle, it's cardboard, and I got a piece of string. Right? I take it from the center, take the string out to the edge of the circle. That's my radius. Then what I do is this. Everybody watching? I'm seeing tops of heads. I want to see eyeballs. Everybody up here. I see tops of heads. There we go. So I took that radius. Now watch, it's a piece of string, so it bends, right? And I took it to the end of the circle, and then I wrapped it around the circle. Okay? It doesn't go all the way around the circle. It just goes a certain part around the circle. Would you agree? You follow me? I take this distance right here, so the people online can't see me doing this with my fingers, but I take this distance right here, and I wrap it around the circle. Now, this is not going to be very pretty, but tell me approximately where. That's probably pretty close. Maybe a little bit too long. But so I tried to approximate taking this radius, a piece of string, right, and wrapped it around the circle. It would probably go to about right here or so. Would you agree? That's pretty close. Maybe not perfect, but it's pretty close. See what I'm doing? Okay, I'm going to do it again. Watch this. I'm going to take that same radius and I'm going to stretch it. Tell me, where do you think it stops? Maybe about right there. Okay? So let's do this. Let's change this into different colors so that we can really see them like that. Okay? And let's do it one more time. And let's make it a different color. Make it blue. Watch. Now again, I probably didn't do it perfect, but it's going to come to about right there. This one looks a little bit longer. Pretend they're all the same length, okay? Just pretend, all right? But I didn't go all the way to the 180, did I? So how many of these radii, right, the radius, that's plural for radius, how many radii stretch from 0 to 108? Well, yeah, to 180. A little bit more than what? 3. What number are you familiar with that's just a little bit more than 3? Pi. Exactly right. So guess what? This little bit right here, let's make that another color, green. Okay, so let's make this, and we got to go back to that point size again. Okay, this little bit right here, oops, there we go. That little bit right there is, guess how much of the radius? It's 0.14159 blah, 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 blah of the radius. That's where we get pi from. You probably never knew that, did you? On where we got pi. That's where we got, well, there's another reason we got pi, but this is part of the reason we got pi. We take a radius, we stretch it along here, we take the same radius, stretch it again, take the same radius, stretch it again. It comes just a little shy of 180 degrees. So we call every one of these, we call a radian, all right? And let's go, what color? Let's use purple, okay? So watch this. This angle from here to here is considered to be 1, oops, that's too fat. This is 1 radian. I'll just put RAD for radian. The angle that's made, listen, this is really important, don't lose me now. The angle that's made from taking the radius and stretching it around the circle, you hear what I just said? The angle that's formed by taking the radius, picking it up, stretching it around the circle, the angle that's formed right here is considered to be 1 radian. So if this is 1 radian, then, boom, and let's make that a little thicker, right there. So this would be how many radians? That's 1. This one in here would be another radian, agreed? And then this one, oops. And then this one right there would be another radian. So here's 1 radian, that first one we marked. Here's another radian, so that's 2 radians, right, from the beginning. Yeah. From here would be how many? 3 radians from the beginning. And then what if we got exactly to 180 degrees? How many radians is from 0 to 180 degrees? 3 and a little bit. What did we say that 3 and a little bit was? Pi radians. That's right. Okay, because pi is just a number, right? So 1 is a number, 2 is a number, 3 is a number, but pi is a number, 3.14 is a number. So this is pi radians. So 180 degrees can be written as pi radians. We don't usually put RAD, though, for radians when we talk about pi. We just say it's pi. All right, it's kind of weird, but that's what we do. All right, so we say that this is pi, oops, that made it worse, pi radians. What do you think it would be right here? Look, we go all the way around. If this is 1 pi radians, what's another half circle? It's another pi, so guess where we are right here? We are at 2 pi radians. You see it? From here to here is 1 pi, 3.14 radians. This is another 3.14 radians. So how many radians altogether is a whole circle? Whole circle is 2 pi. Let's do this. What would it be at 90 degrees? How many radians? How many pi's at 90 degrees? Well, from here to here was 1 full pi. What is it right there? It's a half a pi, or we write it pi over 2. What would it be down here? Look, this is 1 full pi, and this is a half a pi. What's 1 1/2? 3, and then we write it like this. You could say 3/2 pi, but it's 3 pi over 2. So watch this. You might be able to do some of these on the worksheet, but watch this. 180 degrees. Every time you see 180 degrees, what does that equal? That equals pi. So I'm going to give you a worksheet. I don't expect you to be able to do everything on the worksheet because I could have used another 5 minutes or so. But every time you see 180 degrees, if you replace it, are you listening? If you replace 180 degrees with pi, then you should be able to figure out how many radians is something in degrees. Okay? All right, enough of that.